Hello, my name is Vladimir Chikin. I am a deep learning research engineer in Huawei, and now I would like to present our new approach for quantization of Winograd convolutions based on channel balancing. It is well known that the minimal filtering algorithm for computing M outputs with k-tab filter requires M plus k minus 1 multiplications instead of product of M and k for the direct algorithm. Later, the Winograd's minimal filtering algorithm was generalized for filters with two-dimensional kernels. Traditionally, the two-dimensional Winograd convolution algorithm is written in the presented matrix form. The quantized Winograd convolution is represented by the following formula. The multiplication in the Winograd domain is the most computationally intense stage. Therefore, acceleration of that stage by quantization is very desirable. The significant speed advantage of quantized Winograd convolutions motivates the research in this direction. For example, look at the following table. As you can see, using quantized Winograd convolutions allows us to speed up the inference time of ResNet 18 model more than 2 times relative to float 16 direct convolutions. However, often the quality drop of quantized Winograd convolutions remains unacceptable. We found one of the reasons why the quality drop of Winograd convolutions during quantization is very serious. It is a significant disbalance of the data ranges in the Winograd domain. We can divide the channels of the Winograd domain input by special balancing coefficients omega and multiply the corresponding channels of the Winograd domain filter by the same balancing coefficients. The filter channels are balanced offline. The proposed technique is presented on the demonstrated formula. If we set omega equal to 1, then this formula will be reduced to the baseline form. If the balancing coefficients are chosen correctly, the new Winograd convolution is easy to quantize, since the channel ranges of Winograd inputs and filters become more balanced. For the case of post-training quantization, we propose a special direct algorithm for calculating the balancing coefficients without additional model training. This algorithm can significantly improve the quality of post-training quantization for Winograd convolutions. Moreover, we can initialize the balancing coefficients using this algorithm and further train them as trainable variables for greater quality improvement. In addition, we would like to note that the relative complexity of balancing is very insignificant. The following diagram shows the ratio of the expectation of the standard deviation of channel ranges after balancing to the one before balancing for inputs and filters of our Winograd convolutions for ResNet 20 model for two different Winograd algorithms. In the great majority of cases, the channel balancing significantly reduces the deviation of channel ranges of Winograd inputs and filters. In our work, we compared the quality of traditional and balancing quantized Winograd convolutions. To this end, we conducted experiments with different architectures for image classification tasks. We made experiments for different quantization types, bitwidths, and various Winograd algorithms. In these results, we obtained that using channel balancing significantly improves the quality of the quantized model with Winograd convolutions for both post-training quantization and quantization-aware training cases. The following table shows the results of quantization ResNet 20 model with Winograd convolutions on CVPR10 dataset. The results for other image classification tasks can be found in our paper. In addition, we conducted experiments for 8-bit post-training quantization of efficient subpixel CNN with Winograd convolutions for image super-resolution tasks. The obtained results show that the quality of the model with balancing quantized Winograd convolution significantly exceeds the quality of the models with traditional quantized Winograd convolutions and is close to the quality of the full precision model. In the result, the proposed technique demonstrates a serious impact. Well-known quantization techniques for Winograd convolution show better results in some tasks, especially in the case of more efficient Winograd algorithms or in the case of post-training quantization. The proposed balancing technique allows you to get much better results in these tasks. Thank you for your attention.